Oh.
All right, so we're back online. Okay, we're back online. Oh, by the way, make sure you bring your calculator from now on. We're gonna talk about more calculator questions. Make sure all you guys have calculator. If you don't have one, just go borrow one from library. It'll work too. And just gonna keep it until the thing is like, yeah, it's a very expensive calculator. Not everybody can afford it. So, again, we will start with a definite integral. Definite area, integral was area under the curve, and we are talking about definite integral is the exact area. But we're gonna start from approximation lead to exact, and we're gonna show you how that happened. So we start with the approximation. We start a right Riemann sum, okay, or left Riemann sum, or they call that right endpoint approximation. So they can also name as a right endpoint approximation. We're just going to start with talking about approximations. So there's a right. So also this, they call it right GHT endpoint approximation. Okay, we're going to say right endpoint approximation or left endpoint approximation. You can have the third one is called midpoint rules, that's an interesting one. And usually people make a lot of mistake with that one. And one of the most popular one is going to be a trapezoid. Yeah, for AP exam. They love to test you trapezoid rule. They love to test right and left, but not all the time they test midpoint because there's so many make mistake on midpoint, and we're gonna talk about what kind of mistake they will make, and only specific kind of things can be at midpoint. So it's a little bit different. So at first we're gonna go into decimals. We're gonna show you how this works. And we're going to also pay attention on two things. So we're going to pay attention when it's over approximation or under approximation. Okay. And why does it has over or under? Why, right? We have to understand why, because on College Board it's gonna ask you to justify something, and you're gonna have to provide a reason. You don't need it. You don't need a whole page essay. You only need like 3 words to explain something. FRQ. So you probably think like FRQ you have to write essay. No, you do not have to write essay. You want to write one sentence at the most. At the most is 1 sentence. So each one is not like something very difficult. Pay attention when's over, when's under. So we're going to start with this equation. So what we're going to do is, if you guys ever pay attention, that we're going to go use this functions, and we're going to make that function a little bit different. We're going to say x squared plus 1 and 2. And then we're going to say start with 1, or start with 3. And we're going to say steps is, that says 10. So, and we're going to change this between 50, like this. Okay, so we're going to change to 4 rectangles. And if you see that if the function going up, right? Now let's first talk about what I learned. Like I remember everything I learned a lot of time. And one thing is very clear memory when I was younger, when I was like 3rd grade, they talk about like if there is a tree And they say, what if there was 3 trees? How many space between the trees? So obviously by looking at it, there's 2 space, right? And if the 4 trees, how many space? 3. So then if you have 1,000 trees now in a row, how many space in between?
999.
So it's always n minus 1. So among the trees, subtract 1 is going to give you amount of space. And that I didn't understand that when I was younger, and until like teaching calculus, I realized that's kind of important to know. So imagine there was a 5 points I can use, right? And obviously there was only 4 different height of each rectangle. But which ones determine the height? Well, for the right end approximation, it's a 4 rightmost points. So that means I'm going to excluding the 2. I'm going to use the height of this point. I'm going to use the height of this point, this point, this point. And realize I did not use the height when the x is at 2. Do you see that? And I use the right end, I draw it, and learn how to draw based on the right end point. When they come back across this point, and they're going to use that point to draw a rectangle again, and that's going to be it. So that's right approximations. Is this over approximation or under approximation? Over, because we got extra area that's uncountable for. Then, now here's my next question. How do I make this approximation better? Add more rectangle, right? And I'm going to show you the visually. If I add to 10, the space, the extra space is a little bit happen more often, but it's much, much smaller compared to, let's just say, 4. As opposed to 10. And also you can see the area too. You see the area is 21.88 for right end approximation. When it's at 4, it's actually 23.75. So it's actually going to be better. And the exact is on the bottom is 20.666666, which is 61 over 3. So it's 62 over 3, sorry. 62 over 3. And that's the exact area. Then if you break to 10 pieces, it went from 23.75 to, that says 21.88. Pretty accurate. It's off by a bit. And what if I change to 1,000, right? What if I change to 1,000? Hopefully my computer doesn't crash. But yeah, you can change it to 1,000. And you're going to be like, oh my God, there's 1,000 pieces. Even though small here, so it's very, very tiny, tiny pieces. And if you go into the thing, you say, that's going to be exact. But the truth is not. Because each 1,000 pieces, they all have a small extra area that you cannot see it with your eyes in current scale. But if you zoom in enough, lo and behold, you see those 1,000 pieces have extra space coming out of it. And it's still over approximation. It's still over approximation. So that's something that very, very important for students to see. I don't know why that extra things. Oh, I know why. They're trying to calculate the area of a trapezoid that way. But they did it wrong. But let's not worry about it. So in here, then we find out, well, we can break 1,000 pieces, or we can go back to 4 pieces, and they don't go back, unfortunately. Yeah, they don't go back. So we're going to go back and restart again. Hopefully they will recalibrate. And let's go into 10 pieces back again. So now with this function, It's not exactly, we cannot tell whether they are over or under, because some are over, some are under, and we just hope our luck, they'll average it out, there'll be a good approximation with this particular function. Now we're going to go back to that function that we did before. There was a reason why we start with that function. So we're going to say x squared. We're going to say x squared plus 1. And 1 to 2. And that's going to be this. Okay, so I'm going to change this scale a little bit, maybe y to 50, so I can tell it better. Okay. So that's if you break to 10 pieces. Now, this is right hand approximation. Now, if I do a left hand approximation, I might just do it in terms of 4. Right? Now, this one's under approximation. You see that, right? Now, you also then use the last point. You use the rightmost points. Do you see that? Between 1 to 2. Oh, we did a 2 to 4, sorry. We did a 2 to 4. So that way we change that. So, if you see, I did not use the last point. I did not use the height of last point. Do you see that? Now, how do I make it even more accurate with just 4 rectangle? Is it possible I can make more accurate? What? Well, we didn't say, we say still, we stay as a 4. We don't want to add more point. It's any way that I can make it better approximations. Midpoints, good. So what happened is midpoint. What would they look like? So instead of using 2, 2.5, 3, and 3.5, which x value I'll be using to get a y value? Which x value you think I'll be using?
Go in between, so it'd be 2.25, 2.75, 3.25, 3.75.
Basil, you're a genius. Except the way you take a picture, but
I use trackers that, yeah, not my proudest of me.
okay, so midpoint is a better. And you see why that better, right? It's you pick, just like what Basil told me, I pick a point in between those intervals. And this value is better, and just look at how much accuracy with this. It's insane accuracy. It's 20.625. Opposed right endpoint is 23.75. Really off by a whole lot. But the actual value is 20.66. So you are literally 400th, like 4 out of 100, 400th away from being the right answer. So it's pretty good accuracy with this. So midpoint is one way to do it. And you got to remember, it's used between 2 points. Between 1 and between 2 to 2.5, it's going to be 2.25. Between 2.5 and 3, it's going to be 2.75. And so on and so on. Now, let's pay attention. What is a trapezoid rule? Right? And we're going to talk about over or under approximation again. But we're going to talk about trapezoid next. And what will trapezoid look like? But trapezoid look like this.
How's that an approximation?
Are they over or under though? I don't want to zoom in, but can you tell me, are they over or under right now?
I guess I would.
Why do you think it's over?
Symbol up there.
Yeah, you can, of course.
So like a trapezoid is like, you know, it's that box with the slant. So in a formula like this, the curve is going like that, but the line would go like that. So like there's going to be a dip where the trapezoid would go over.
Right, but there's also going to be points where it's under.
So is it over
Yeah.
approximation?
But in this case, it's like the curve of the line of the x squared, it would like dip inwards. It'd be, the slope would be less than 1, whereas the slope for the trapezoid would be greater than that.
So which kind of characteristic you are trying to point out of this curve that is causing the over approximation?
I think it will be an over approximation more
Good
towards
job.
the-
Good job. Ethan said it.
Due to what?
Concavity.
Concavity.
That's the thing.
Look at the functions concave up, right? And if it's concave up, it's going to causing this happen. Do you see that happen? Because it's concave up, so you have that dip, just like Basil was saying, but he just cannot speak calculus, but he speak common sense, right? A common sense, there's a dip if you have it concave up. Then if you draw a line on top of it, it's going to have a little bit over approximation. Does that make sense? Now, if it's the other way, that just say, if I show you a negative x squared plus 1, let's say plus 10, that'll be better. And if you see here, it's concave down, and you see that over situations, right? So it's very important to understand that concavity can affect the over or under approximation just as much as anything else. Now, increasing, decreasing in terms of trapezoid, no bearing difference. But what if you have concave up and concave down? Then they kind of like they kind of even it out, right? So you can have function if it's strictly concave up, then you can tell that's always over approximation. If strictly concave down, it can tell the second is actually can tell that's under approximation, but really depends on the concavity difference. So we just talk about the basic intuitive thinking. If worse to worse, you can always choose to draw it. That's a nice thing. You can draw things and figure out. Now, as far as the right endpoint and left endpoint, what's the deciding factor? Are they over or under? What's the deciding factor? If it's the right end or left end?
depending on whether the function's positive or negative.
Not positive or negative?
Not the slope.
Slope. Okay, so slope is positive means increasing and decreasing. So it really depends on if a function is going up. If it's going up, if your right end approximation, it's going to be over. Does that make sense? If slope is going down, if your right end, then it's going to be building a rectangle much smaller than the curve, much underneath the curve. So those are the things that a lot of students that AP exam, they're going to ask you over approximation, under approximation. Students tended to guess. And when you guess with no justification, they don't give you the points. So you not only you have to understand, you can say it's over on the right endpoint approximation because the function is increasing. Therefore, that's a good FRQ answer. As opposed of it's overestimate because it looks like it. And you don't get point because it looks like it. You don't get point because anything else. You have to look at a point. You have to say, okay, the function is increasing right end approximation. Therefore, it's over approximation. Or you can say it's under approximate because it's concave down and we deal with the trapezoid. So those are the things that you should tell AP exam. You don't need to write a paragraph how the function has a dip. Has a dip, it's not going to give you a point, unfortunately. But the understanding will give you a point. Now you just have to translate that to the calculus language. Yes?
How do you know whether it's over or under approximation from midpoint?
You actually don't. Actually, you cannot tell me if anything are over or under unless they are strictly increasing or strictly decreasing or strictly concave up or strictly concave down. There is no justification. If you have a mix of two, let's say increasing and decreasing within the interval, then you cannot tell me it's over or under. Or it's concave up and down within the interval on the trapezoid rule, you cannot tell me over or under. You had to tell me undecided, which is they should do that on AP exam, but they don't. They usually give you one way or another. They don't give you somewhere in between. Yes?
Couldn't you use inflection points if it's both to tell if it's increasing, if it's over or under?
Inflection point, yeah, so depends. You can say before the inflection point is decreasing or is over approximation. After the inflection point is over or under. Depend if it's the trapezoid rule we were talking about. Yes, then you can say that. But they don't ask that type of question. They're going to ask you is over or under and why. That's it. And the function they give you to you more likely strictly increasing or strictly decreasing or strictly concave up or strictly concave down. Okay? Okay, so that is a trapezoid rule. And trapezoid rule, you just had to find the area of trapezoid. So let's talk about, we talk about right end, left end, midpoint, and trapezoid rule. Now, for AP exam goes, unfortunately, we study for the exam. At the end of the year, if you want to get a credit, you do have to understand the format of AP exam. And that's what I'm actually more expertise at, the way that they will ask you the question. So I'm going to coaching you through passing the exam. Every single person can. So the first thing they would love to test on approximation is they give you a table. Table is the most popular one. I think 100% of the time they give you a table. Table is not, it's the easiest way to do it. And they try as much to give you easy point. And this is the easy point you have to earn 100% of the time. The second one they can ask you is a function. And sometimes they don't give you, they give you some interesting function in the past. But they can give you a function. You have to go in to figure out each values. And yeah, this is actually not so popular, but the first one's more popular. The third is actually they give you a graph. Now, this one is I predict in the future they will start doing that. But currently, I don't see any graph questions. But they can give you a graph. But we can be 3 situations tomorrow. You can practice on those special cases. Zach, you okay? You tired? Okay. So make sure you pay attention to this part. In terms of table, they can give you 2 different types of table. They can give you a regular interval, which is each rectangle is exactly the same width. And that's kind of boring. But for us regular, you have to pay attention at the midpoint rules. Because only midpoint can apply on the regular. Midpoint does not apply to irregular interval because there is no middle of 2 points if you're irregular. So irregular is the most common one to test. If it's irregular, they're going to ask you right, left, and trapezoid. And they're not going to ask you midpoint because they're irregular. Function. Functions are actually interesting. Sometimes they can give you a function and ask you to figure out. AP Calculus teacher tended to ask that more often than AP exam. I like it both, but graph, you just have to be able to tell what is the y value. So regular interval or irregular intervals, that is going to be the way that they're going to asking. Now, I'm going to show you a regular intervals. Also, you want to figure out each width of a regular. So regular interval, if you want to figure out each width, then it's actually only for regular is a b minus a over n. N is among the rectangle, so it's between 1 to 9. And if you have break up 4 rectangle, therefore 9 minus 1 divided by 2 is 2. Or divided by 4 is 2. So what kind of regular table they can give it to you? They can give you f of x right here. And they give you a table, they say x. And we're going to say 1, 3, 5, 7, and 9. And each x value, I'm going to give you assign a y value, 12, 10, 8, and 9, and 5, something like that. Let me ask you. With all those 4 values, or 5 values, how many rectangles are they? Can you maximum have? Huh? What's the maximum amount of rectangle you can have? 4, because you got 5 values, right? If you got 5 trees, then there is a 4 space in between. But that also means we don't have to use 1 values. So the way I kind of write it for regular interval, so this is the case, is a regular. How can I tell it's y regular? 1, 3, 5, 7, 9. It's pretty uniform. It's all odd number. So each number in between is 2. And that's it. Now, do they have to have regular? No. They actually prefer to ask you irregular. So we're going to give you both examples. So at first example here, I'm going to say write an approximation. Or write Riemann sum with 4 equal rectangles. Can you figure out what would be the area under the curve in this case? Now, remember, I didn't give you a function. I give you a table. That means you have to use the table value to get it.
Did you say n was the number of spaces?
Yeah, there are 4 spaces because there are 5 values.
And how do you know whether it's over and under for midpoint?
For midpoint, you don't know they are over or under because the midpoint it really cannot tell. It depends on the slope before the midpoint or slope after the midpoint. So it's very, very hard to tell. And just like what Ethan's saying, like inflection point, those are really hard to tell. So how do I do with 4 rectangle in this case of even intervals here? Yep.
I multiplied, well, I turn it on the right side because you won't use the 12 because you're right hand. Just on the right side. So I just multiplied the y values or f of x by 2, so there's 2 spaces between each value, and then you add them up.
Okay, so 2 times what?
2 times 5 plus 2 times 9, 2 times 8, 2 times 10.
And that's it. And you're going to get 10 plus 18 plus 16 plus 20. And this is 30, 50, 64? Does that make sense? And you don't need that. You don't need a calculus. Be a calculus student to figure out this. You can actually understand this if you're elementary school. You can actually get this question correct on AP exam. Pretty straightforward. What if I use left end? Use left end. Now be careful of the question. With the 2 equal
Why do you number it 3?
rectangle. With 2 equal rectangle, but use 2 left. Okay, 2 left end approximation. So be careful with this one because I'm only going to use 2 rectangle to approximate. Xavier?
You would use the exponent at 9 and the exponent at 5. Or sorry, obviously you use the y value.
Thanks for another great Titan day.
The y value, no, is at 3 and 7.
Oh, sorry, 1.
And each rectangle is going to be 4 instead of 2.
Sorry.
So that's why people's going to make mistake because it is 2 rectangle, right? So b minus 8 over n. So in this case, 8 over 2. So be 4. 4 times 10 plus 4 times 9. And each individual 1. So that's equal to 76.
Why did you choose 10 and 9?
Because I use a midpoint between 1 and 5, the middle is going to be 3. And between 5 and 9,
Yeah, you said left end.
oh, left end. Oh, sorry, left end. So left end is going to be
12 and 8.
Oh, okay.
12 and 8. My bad.
Is there homework?
No, there's no homework today. We're going to do actually a lot of things tomorrow. So it's going to be 12 and 8. So it's equal to 48. But you have to finish the multiple choice. Then you're good.
You put the answers up?
Yep. No, not yet. But I accidentally posted on the, I supposed to post on BC, but I actually posted on the AB by accident.
You took it down?
I took it down already.
Wait, so why did you choose 12 and 8?
Because I use left end. If I use a mid, then I will use 3 and 7.
So, 12 is the y value of the leftmost.
Why did I multiply by 4? It's because between 1 and 9 there is 8 spaces, right? But you divide it by what 2 rectangles. So 8 divided by 2 is 4. Huh?
But then wouldn't that be midpoint?
Now, if
It didn't matter. It's still 2 equal rectangle. It didn't matter if I use a mid or left or right. If I use 2 rectangle, then each width is going to be 4. Because b minus a over n. Does that make sense?
Yeah.
You sure? Okay.
you didn't want to hang out, are you going?
Alright. Thank you, Mr. Guy.
Bye. Holy shoots.
What happened? None of my business, sorry.
No, stock is going down.
Oh, that sucks.
It stunk.
Smokes.
Wow.
Is it like going down hard?
Yep.
Oh, that sucks. You put a lot of money in there?
I mean, it's okay. I mean, overall, it's okay. It's I have positive return, so it's not a matter. It just it cut my profit a lot smaller, but stock is always gonna go up and down. And just one day you feel like it's up, you're making a lot of money, but next day it's down, you feel like you're losing a lot of money. But in truth, it's kind of in between. You just have to keep on put more money in there when they are low, and then when they increase, then you have a leverage. But you know, so that's why they call it buy the dip. But it's really hard to buy the dip because emotionally you see the stock is going down. You don't feel like buying, you're feeling like selling. It's actually a reverse idea. So when the stock keep on going down like crazy, and depends, so they call it catching a falling knife. If you're catching a falling knife, you're gonna get burned too. So you have to wait until the knife fall on the ground, and then you buy the dip.
Yeah.
But that's the art of that. Like people always thinking doing the stock, especially also your age. I was thinking buy stock so easy, just buy low, so high. But the problem, your emotion doesn't really tell you to do that. Your emotion when you see your money, when the stock you buy for $100 is going down to $80, you don't think about buying more because you feel like you lose $20 already.
Yeah.
And you don't feel like buying more. But actually, the truth is, you cannot buy. So you actually, the best way to invest is not buy the dip because nobody can predict where the dip is.
Yeah, you can't predict when it's gonna start going up and like to buy it earlier.
Yeah, you can predict like nobody in this world. It didn't matter how good of the trader you are. There's no way you can predict anything. So the best way to invest is actually called dollar cost average. A dollar cost average is, for example, you have a share of $10, right?
Yeah.
And so you buy one share of $10, and then you see them drop to $5, and you sell, and you lose $5. But that's not smart. If it went down to $5, you're gonna buy one share again. So in this 2 share, you have average of 7.5 per share. Okay, so the stock is still at $5. It went down lower. It went down to $2. And you buy one share again, $2. So now it's 17 divided by 3, right?
Yeah.
So 17 divided by 3 is roughly $6.33.
Yeah.
And now its stock is gonna stay at $2. Now you don't buy a company like selling like weed, right? Because if you buy a company selling weed, that's gonna happen because they don't have a positive cash flow, they don't have proving of track records. They just because people buy in terms of excitement. Oh yeah, this weed, everybody's smoking weed, so everybody's gonna buy that. So then you said you don't buy those stock. You cannot buy those stock pure out of speculation. You buy stock like Apple and Google, it's not gonna bankrupt anytime. So their stock will never become zero. But they can go down. For example, a stock of Apple went down from $160 to $120. And you're like, oh my God, it's the end of the world. I'm going to start selling. I lose 25% of the money I have. So invest $10,000, I'll lose $2,500. So what happened is if you keep on doing that, if you're buying a stable company, the company is not going to stay at $2 because they're not going to bankrupt. Like Apple, it's not going to bankrupt. Everybody's using it.
Yeah.
So then it went back up. So when it went back up to $6, you already break even. You don't have to went back to $10. You just $6.33 and you make money. You can start money. Now, in case it went back to $10, right? In case you go back to original money you pay for, like $10 on the first share, then you actually make $3.60 on each share, so you make $10 already. So you don't have to go all the way to $12 to make money because your average is dragging up your average down. So that's called dollar cost average. So it went down, you don't buy a lot more, you just buy a small amount, So the best way to invest is you buy, they call it SP and 500. SP 500 is the top 400 company in the world. So those companies will not bankrupt. For example, Tesla is like that, Apple is like that, Google is like that, Samsung is like that, McDonald's, Chipotle's. Yeah, so all those are S&P. Or even better, you can buy just S&P. So it's average of those top 500 companies. So you can buy, they call it SPY. SPY is S&P 500. So you buy those companies, that's it. So if you were to buy, and if you put $100 each day, so from let's say 1980s, and you put $100 each day, let's say you put $1,000 each month, right? So every month you probably put $10,000, right? Every year, so about 12,000. So 12,000 times 20 years, so it's going to be 240,000. But because the compound interest, everything going to go up, it's also inflation too, everything got more expensive. You earn easily $1 million already. Wow. Because the thing's going to double and double and double. Because the annual percentage, the return for the last 10 years is like almost 8 or 9%. And it's very good. But the problem is people get emotional when they buy a stock. They buy a stock, oh, they see Tesla's going up, they buy. And I did that before, so I know what it is like. So it went up to like $1,200 and you buy, right? And next thing you know, when you buy $1,200, it went back to $1,000. It went back to $800. And you feel like losing money and you sell, right? Because your emotions start getting best of you. So you sold at $800, but that's the time you should buy because it went back to $1,000. You're like, shit, the stock going up, and you buy again, but it's already $1,000. But you could have kept it. You only lose $200. Well, smart decision is you buy $800, right?
Yeah.
If you buy $800, your average is $1,000. So by the time you go back to $1,000, you already break even. But now you have two shares. And two share, if we go up to $1,100, then you make $200 just based on two shares. So those are things it's kind of like, I wish school, instead of teaching calculus, they should teach kids how to be financially smart. Because that's your livelihood, right?
Yeah.
It's not a point as you knew how to do calculus. Now, is that important for calculus? Yes. But not every student need to know calculus. I don't need some student want to be a businessman to know calculus. I need an astrophysicist to know calculus. So the problem education system is fraud. And the fraud is due to like College Board, like situation like College Board. Like College Board wants you to take all those AP exam. They say it looks good in college. But the truth is, what's the most benefactor? It's College Board.
Yeah.
More people are taking it, the more government had to pay for it, right? So they have a perfect sales pitch. They perfected their sales pitch. A College Board is like, oh yeah, you should take SAT. A long time ago, you had to pay to take SAT. Now they just charge the government because they have students take SAT. But you have some people just falling asleep
Yeah.
in like first 10 minutes and they Christmas tree the rest. And how many people in a classroom? Like 40%. Minimum. 40%. Almost 50% of students, they just fall asleep. You've been to the SAT room before.
Yeah.
You take it, you see some people just falling asleep. And you're
Yeah.
like, what the hell are you doing?
Exactly.
But who's the most benefactor? College Board.
Because it's getting all the money anyway.
Yeah. It didn't matter the kid falling asleep. So for me, College Board is like a very, very big scamming. Even though I teach AP,
Yeah.
I really absolutely hate it because for me, like teaching how to add a rectangle, that's not calculus. The calculus is understand how do they go to infinite.
Yeah.
And that's probably the biggest thing I would say to